Yeah, hi class. So till now we have already covered all the topics of GSM module, and in previous classes we covered GPS, all the topics related to GPS, in which we saw how we can get date, time, latitude, longitude, and all the related information that we can get from GPS device. Today we are going to start our new topic, that is BLE, Bluetooth Low Energy. So can anyone tell me what do you have you previously used Bluetooth or not? Ripu and Sandeep.
No.
No? In your mobile phone, you must have used it.
Oh, yeah, yes. I thought Bluetooth module. Okay.
So, can you tell me what happens in the mobile Bluetooth?
Yeah, in mobile, if you on the Bluetooth and it will search for the another device, Bluetooth device.
Okay.
So when it is connected to another nearby, like if it is in the range, if it is connected to another on the Bluetooth device, then it will be connected and paired up. Then we can transfer the files, whatever the files, photos, audios, videos, anything, we can transfer it to and from.
So, using Bluetooth, we can transmit our data from one device to another device without using any net data. Like in GSM, we needed a SIM card with valid mobile data recharge in it to transmit our information from one device to another device. But what if we don't have any data plan? So without IoT connectivity, if you want to transmit, then you need to use wireless connectivities, and Bluetooth is one of such example. BLE, Wi-Fi, Zigbee, these are the examples. So using Bluetooth, we can wirelessly transmit our data from one place to another place.
Yes.
Yeah. So I'm just going to share my screen and tell you how we can get that setup and all. So just let me know once my screen is visible. And we'll cover this Bluetooth in 2 days. Theory part will cover today, and connectivity and all part will cover in next class because it's a little bit longer tutorial. So can you see my screen?
Yes.
Okay, so I'm going to follow Bluetooth documentation from provided by ST. So this is my ST Microelectronics website. I'm just pasting this link in chat box. Ripu Kumar, what's the language problem? Can you tell me? Balmiki sir?
Yes,
Uh, please see what's the language problem with Ripu Kumar.
I think Ripu wants in Hindi, I guess. Hi, Ripu. I think try to understand this. Okay, so it's not like high level English we are talking. Okay, it's a yeah. So
Yeah,
try to understand.
no, there is no issue with Hindi. We can cover it in Hindi, but most of our students will not be able to understand it, I
Understand?
think.
Yes.
A majority of our students will be able to understand it in English, so we are going to cover it in English. But anyhow, if you have any problem regarding language and all, you can connect with me personally over chat. I'll solve your doubt. Meanwhile, if you have any doubt, you can ask in Hindi also, Ripu Kumar. So I have pasted two links in chat box. First, click on the first link, everyone. this page will be opened. In this, you will get overview of BLE. So what is Bluetooth Low Energy? So here you can see BLE is a low power short range wireless area network. As I have already told you, BLE is a type of wireless network. So BLE is a low power short range wireless personal area network technology designed and marketed by Bluetooth SIG, a special interest group. So all the features developed are when we will go to do all the setup and connectivity, you will use SIG feature. So there SIG means a special interest group to allow devices to communicate with each other. What are its key features? Here you can see it reduces battery consumption as it's low power, so it will reduce battery consumption as the amount of transmitted data is low, creating simultaneous connection as in Bluetooth. So for example, have you used Bluetooth with your mobile phone?
Yes.
And same Bluetooth you can connect with your laptop also.
Yes.
You and same if you are using one laptop, okay, in that you can connect your Bluetooth earphone with Bluetooth. Then you on the same laptop at the same time you can connect your wireless mouse using Bluetooth,
Yes.
and at the same time you can connect your wireless keyboard also with the same laptop or desktop using Bluetooth.
Yeah.
Yeah. So with one device you can connect multiple Bluetooth devices using using BLE. So it is used to creating simultaneous connections. So all these connections are simultaneously. Third point, developing a standardized application specified by Bluetooth. So using this, you can develop many applications. One such example is Bluetooth that is used in your mobile phones for music and all. Developing mesh network application. So what is mesh network application? Can anyone tell me?
Like one to
What?
many or many to one.
Yeah, so mesh network is something like interconnected network in which there are multiple nodes and all those nodes are connected with one master node. Okay. For example, your laptop is one master node and all the Bluetooth devices like earphones, wireless mouse, wireless keyboard, these are different nodes. So using this, you can create your mesh network. Developing application with flexible services, that this we will see. For example, most smartphone and tablets build this, so this is common. Yeah, in STM32, you can get Bluetooth in three series: WB series, which we are using, STM32 WB55RG series, STM32 WB0 series. In this also you can get BLE. STM32 WBA series. In this also you can get BLE. So if you want to use BLE in STM32, you have to use devices of either WB series, WB0 series, or WBA series. Okay. Now these are the Wikipedia pages. From there you can see all the setup and all, but we will see it, so no need to take it from here. Yeah. So from a hardware point of view, ST Microelectronics offer various ports to set up Bluetooth. I have already discussed it. Like in WB55RG series, you can get the hardware which will be able to connect with Bluetooth. These are the evaluation boards in which BLE will be available. If you want some application notes, you can get from there, but you will not need it because I'll tell everything in detail in this class. For bring up and all, you can get from documents from there. So we will not need all these things. Yeah. Tools you will need STM32 Cube Programmer or Cube ID. So we have already installed STM32 Cube ID for our previous projects. Yeah, there will be some terms that will be used in our setup. Please have a look. ACI, this means Application Control Interface. So all the interface related things that you will configure in your Bluetooth, this will be named as ACI, ACI underscore and with some other names. ATT is attribute protocol. So whatever attribute you will be using in your Bluetooth, you will get to select it from here. Bluetooth Low Energy BLE Development Kit Gap Characteristics. So this is generic access profile. I'll tell you in detail when we will be configuring our devices. GAT properties, generic attribute profile, HCI for clock purpose and all, host control interface, L2 cap, MCU. So these are the some things which you will be using. Radio frequency, yeah, these three things are very important. SIG, so a special interest group. UUID, this is unique identifier. So can you tell me how, when you connect your mobile phone with your earbuds, how does your mobile phone know that this is the correct earbud which which I have to connect with my mobile phone?
Device name and some device ID.
Yeah, so there is some device name, and along with them, there is some ID which is known as UUID. This is unique identifier ID. So whenever you will configure or create any Bluetooth device, you will have to give this UUID, which will be unique, and using this, your device will connect with Bluetooth. WPAN, you have to configure this also. This is wireless personal area network. That's all regarding this. Now we will move to setup. So for that you will use this second link. We will be using GATT server application. Already I have explained you what is GATT. This will expose characteristics. So GATT will expose characteristics of your Bluetooth. For example, if your Bluetooth will be able to transmit only text data or musical data or video data, that you will configure from here. Then you will give your BLE some name, that is P2P server or P2P client, anything, and then in its characteristics you will write things like, can your BLE be able to write, or it will be able to only notify, or it will be able to read, or it will be able to do all the three things. Okay.
Okay.
So these are the examples and all. This is the same Nucleo board which we are going to use. These are the steps which you have to follow. Okay, let's forget it. I'm just opening my Cube ID. This is my previous projects. So I'm closing all these things. Okay, now I have already told you how to create project, new STM32 project. Here you will give your board name. So STM32 WB55 RG V6TR. Okay. Here you can also see Bluetooth 5.4 is supported. Now next, give it a name. So I am giving it name BLE. Finish.
Zigbee is also available.
Sorry,
Zigbee.
Zigbee.
That is also available in the board.
Yeah, Zigbee is also supported in this board. Now go to this system code. In this you will get this HSTM activated. Why I am activating it? Here you can see in this tutorial. Here you can see activate HSEM, activate IPCC, RCC, RTC, activate RF, and STM32 WPAN. So I'll activate all these things. So HSEM is already activated. Now IPCC, activate it. Do I need to enable their interrupts? So I'll check from here. No, IPCC activated. Interrupts enabled. Yeah. Here you can see IT is enabled. And there also they may. So HSEM I have already activated. Its global interrupt is also activated. Just move there. Go to this. Global interrupt is already activated. Then select IPCC activated. Go to NVIC tab. Enable RX interrupt and enable free interrupt. Here you can see. So I am doing the same thing here also. IPCC enable both interrupts. Now again I'll follow the document. Here RCC, select RCC, choose crystal for HSE and crystal for LSE. So move to this RCC tab. Here crystal for HSE and crystal for LSE. And do I need to activate its interrupt? I'll see from there. No, its interrupt is not enabled, so I will not be enabling it. Then go to this RTC section. Here you will not find RTC, it will be in timers. So here RTC is there. Activate clock source. Set wake up as internal wake up. Sorry. Here wake up as internal wake up. Then go to NVIC tab and enable wake up interrupt through EXT line 19. So move to this and yeah, here I have enabled it. Then move to RF, select RF and activate RF1. So RF will be in connectivity. So move to RF, activate RF. And what was it there? Select RF, activate RF1. So I have activated RF1. Now to enable BLE, go to STM32 WPN interface, select WPN and select BLE and enable it. So I'll move to this tab. Here you can see STM32 WPN is here. Select BLE. After selecting BLE, okay, I'll leave these things as at default. Then move to clock configuration. So I have enabled BLE. Now move to this clock configuration. It's showing some error here. Run automatic clock issue solver. So resolve clock issue, and you can see my clock issue is already resolved here. Then set RTC LCD source, set system. In clock configuration, here I need to set RTC source mux on LSE. So here you can see RTC source mux is selected on LSI. I have to select it as LSE. Then set system clock mux on HSE. System clock mux on HSE. So this is system clock mux. It's set on MSI. I have to select it on HSE. So I have selected HSE. HSE, then select RF wake up clock mux to LSE. So where is RF wake up mux? Here. Where is my RF wake up clock? Yeah, here my RF wake up clock is set on HSE. I have to set it on LSE. So I have selected it. LSE, then SMPS clock mux on HSE and divide it by 4. SMPS on HSE and divide it by 4. Okay, so I'm good to go. Then configure the project, define project name, project location, and all. Then code generator will generate. Okay, so here we are. Now, before generating the code, we'll need to do some setting here in BLE. Can start configuring and defining BLE. So okay, so I have to go there, BLE application and services. So here it is, BLE application and services. I'm already there. Now what I have to do, go to BLE, enable custom template and disable custom P2P server. So there you can see custom P2P server is disabled and custom template is enabled. So custom P2P server is enabled. I'll have to disable it, and custom template is enabled. Because I want to make my own BLE device, which will be custom device. I can give any name or any UUID. For that purpose, I'm using custom template, not custom P2P template. Now go to this advertising parameter tab. I'm not finding my advertising custom here. Can anyone see this? No, I'm not finding it here, so I'll once again go. Okay, it's available here in BLE advertising. So I'll go there in BLE advertising. There I have to go in advertising configuration and advertising elements. So this is my advertising configuration and this is my advertising elements. Sorry. Now open advertising configuration and there give your gap device name. So this is my advertising configuration. Here I have to give my gap device name, CFG gap device name. So it's template set here. I'll give it my BLE. You can give any name here. In example, it's my application, but no problem. You can give any name. Then in advertising configuration, advertising type unidirectional, scannable and connectable. So it's unidirectional, scannable and connectable. Identity is gap public address and privacy is disabled. Public address and advertising filter, no whitelist. Just go there, advertising filter, no whitelist. Okay, so it's correct. Now advertise and connect broadcaster, central and observer. All these settings are no, no, no. I'll just check, it's already no, 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 no. Then I'll have to go to this advertising element. I'll close this and open this advertising element. Here include address type TX power level, yes. Include at type TX power level, yes. Data length, it's already 3, so I cannot change these things. Then include complete local name, yes. Complete local name, yes. Complete local name, I can change it, so I'll take my BLE, or I'll just write my name here, Chandan. So whenever I'll connect my device, it will connect with this name. Okay, rest things are no, 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 no. Then add type manufacturer specific data, yes. No, 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 no. Manufacturer specific data is here. Yes. Okay, so these are the settings. Now go to BLE GAT tab. So this is my BLE GAT tab. Enter number of services, long and short names. Go number of services 1. You can keep any number of services. For example, if you want your BLE device to do 5 services, you can give 5 names here. Now enter long name.
5 services mean 5 tasks?
Yeah, 5 tasks, like one is connecting your Bluetooth earbuds with laptop, another is connecting your Bluetooth mouse with laptop, and similarly, like your wireless charger with your device, and so on. My P2P server and P2P, yes, I'll give this name.
So one chip can connect with multiple services. Is that the case?
Yeah. I think it's maximum is 6. I think my P2P server and short name. And to check short name, what I can give, anything I can give. So I'll give it P2PS.
And then which name will be visible to the
Advertising name which I have set as Chandan.
advertisement?
Okay, this name must not start with please, not empty. Okay, fine. P2P, these are the services name. It will not advertise. It will be used in code. Okay, perfect. Now you can see there is no error in BLE get. Error is in my P2P server. So I'll go there. And number of characteristics to UUID type 128 reduced FE40. So number of characteristics to UUID 128 reduced FE40. FE40. Sorry. FE40 primary service 0x01. So it's default.
Chandan, from where you get FE04? It's a fixed string.
Yeah, here you can see UUID is FE40. There is a document of BLE provided by SIG in which you will get multiple UUID names you have to use. Here you can see a UUID of 0xFE41 is encapsulated in all these things. So from in the BLE document, you can get all these things. I'm just following this document.
So what is the use of this UUID? I mean,
I
you have to-
think I have already explained it. I think you were not present. This is unique identification name for each BLE devices using which your device connect with.
Okay.
Now in P2P server, I have to go and give it name my LED care, LEDC, and all these things.
So Chandan, what if the same UUID is used by some other user?
Sorry.
What if this same UUID
Yeah.
used by other? Because if UUID is a unique identification of our device, right?
Yes.
So what if two chip having the same UUID?
You can have same UUID, but when you will use it, like for example, here you can see UUID is 0xFE41. Okay. But its encapsulated value is 0x00, 0x00, FE41, and all these things. So in your code, you have to use these things, and also there is your local name. So when you will connect with your device will match all these things, and all these things cannot be same. It's reduced. Here also I have to give characteristics UUID. So I'll check from here. FE41 to variable. 41, value length 2, its variable, encryption size is 10. Now these characteristics can read, yes, it can write, yes, and other things, no.
From where we get that encapsulated UUID?
Just search BLE UUID or characteristics UUID by SIG.
No. I'm talking about you have used three to four character UUID, and you have
Yes.
told that it will.
All these data are available on this document, SIG document.
No. My question is, you have explained that this six character UUID will be converted into a long string.
Yes.
So from where we get that long string? Because
In that document only you will get all these details. I'll share this document once I'll find it. Or you can just go to Bluetooth SIG website, and there you can just email them. They will provide you this document. In this document you will get all, I think, 132 UUID names, and below their names there will be encapsulated values also.
so Chandan, anyone can get that ID. So how it become unique? That's my question. How it become unique to our device or our chip?
Okay, so tell me, if you have made one BLE device, so give any UUID number you want.
No, my question is.
No, just give me any UUID number.
From where?
Randomly.
4, 5, 6, 7, 8.
Okay, 4, 5, 6, 7. No, it's okay. 4, 5, 6, 7, 8. Now give me two different character UUID names.
ABC 234.
ABC 234. Okay. Now give me two local names.
Hatim and Chandan.
Hatim and Chandan. Now give me their characteristics, whether they can read only, or they can write only, or they can get notification and all these things that's available in this tab.
Okay.
Okay. Now tell me, what is the percentage that other person who is going to make this BLE device, he will be using same controller that you are using, same two local names that you are using, same three UUIDs that you are using, and same encapsulated values that you will be using, along with the same characteristics.
Okay, but my question is, we have created ABC 234 as a UUID example.
Yes.
So how we get the encapsulated string of that UUID? That was my question.
Yeah, so I have already told you, you will get this from the document of SIG UUID list. There you will get all the UUID values, okay, and below that list you will get all the encapsulated values.
But how we get the value, encapsulated value of our UUID, which we have created?
Just wait. I think you have not focused there. Just let me show you. Okay, so this is just a smaller part from that document. Just read it.
If is 128-bit reduce, UID value 16-bit is enhanced by 180-bit data thanks to copy. XYZ is a service character long name to bring it, for example. So we have to put our UUID in between of that encapsulated string. Is that the case?
Yeah. So when we will generate this code, we will get many drivers related to UUID, related to BLE, and all these things are already taken care by ST in this project. But if you want to do this manually, then go to this BLE SIG document. There you will find UUID like this, and below this you will be there will be written things like UUID 0xFE41, its encapsulated values are, and then 8 to 10 values will be given like this. But in we are using ST microelectronics already developed drivers, so these things are already taken care of. You just need to write this UUID value, and in your here you can see, sorry, not here. In these services, all these things will be in. You will find file like custom stm.c. I will show you when I'll configure all these things.
Okay.
Then and there you will get these functions.
Okay, go ahead.
Yeah. So where we were.
On 5.3. No, downside. Yeah, here we.
Yeah, so I have configured this that my BLE characteristics will read and write without response. Then no, it will notify. So characteristics one get event, it will notify yes, then no. So I have done all the settings for my characteristics one. Then I'll do this for characteristics 2. So my switch 128. I'm not going to give this. I'm just writing my name here also, or just BLE. 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 UUID is 128 bit. FE42 variable. FE42 length will be 2. This will be variable. Rest things will be, this will also read and write. No, default condition no. It will notify no. I think we are done, but let me match from here. Notify yes, then no, yes, no, okay. Now in BLE pairing parameters on. So here where is BLE pairing? Here, pairing parameters on. Then no bonding, fixed pin. You don't need these things. Then in UART, just go and take your mode as asynchronous. You will not need these things also. I don't want my data on UART, so I will not be using these things. Yeah, so I think we are done. Now I'll just generate my code. And here you can see I have got my main.c and all these things for BLE drivers. I'll check in driver section. No. Middleware, no. Yeah, I'll get here from it. Yes. So here you can see in app BLE.c, you will get these bonding modes and all things which we have selected there. All the configuration things that we did. So these are very big drivers. You need to read it for better clarity. Configuration will be available in this app configuration. So very fair.
Where we get that encapsulated string?
1 minute. Configurations are there. Custom app is there. Here you will get all the H files. So I have named my project as characteristics as LEDC and BLE. So these are there. Event handlers here. Yeah, and the custom things that you want, these things are handled here. So they will copy all your UUID and then generate all the custom data. Then event handlers are there. There will be many cases to handle all these things. There they will copy and do all the things. Then H file is here in target. We don't need it. One more file will be there, appconfig.h and appconfig.c. It's not available. Custom app is there, but I don't need. I need app config. Yeah, here appconf.h is here. Here you can see your TX power is there. You can reduce or increase it if your battery is getting more consumed or less consumed. Depending on your use case, you can increase or decrease this power. Then many addresses are there. This is my config device name, my BLE. So all these informations will be available there. So that's how you will generate your BLE project. I'll request everyone to follow the same step and generate their STM32 project. And after that, you have around 5 days gap between this and next class. So I'll request everyone to read all these files so that you can get better understanding. I have already given you the links of the 2 documents which I was following. And after that, in next class, as I have already told you in starting of this class, in this class we will cover theory and a little bit configuration part. In next class, I'll demonstrate you how we can send and transmit data using the BLE device. For that, I'll be using a mobile application STBLE. I'll tell you in detail in next class. So for today's class, if anyone have any doubt, you can speak.
Chandan, I want to clear how we have characteristics, services, and advertising. Okay,
Yes.
so how it connect to the mobile device? Which part is very much important? It will help to make the connection and
For connection and all thing, advertising data is important.
advertising.
Yeah, because your mobile will see only the things that are getting advertised. So if your BLE device is advertising something, only this thing your mobile will or your application will see, and based on that it will connect. But internal, all the things will be needed for security purpose and UUID purpose, like uniqueness.
Okay, so that is what my question is. For example, our STM32 board, we have configured BLE. Okay,
Yes.
we have configured the advertising, the characteristics and services. Now,
Yes.
uh, other party. Okay,
Yes.
uh, which part will make the wall between that they are not able to connect with our STM32 board? That is my question.
If other party is not getting able to connect with your STM32 board.
No, no. My question is, we have set up our STM32 board and
Yes.
BLE. Okay,
Yes.
and uh, we can able to connect with that STM32 BLE from our mobile application.
Yes.
Okay, so other can also connect with our board and send data.
Yeah, if other have known your local name, your BLE local name. For example, my device local name is my BLE or Chandan. So if
Hmm.
other person knows that name, then they can connect with it. But receiving and sending data, for that purpose, they also need write UUID and notify UUID.
Okay, so we have write and notify UUID, right?
Yeah, we have set three UUIDs now. First UUID for our device, then two UUID for two services,
Hmm.
FE41 and FE42.
Okay, so the mobile device required that UUID to build the communication, right?
Yes, when I'll demonstrate it, I'll show you
Okay, got
how
it.
on that particular UUID I'm getting data and I'm transmitting it. But yeah, BLE is not that much secure. With some permutation and combination, it can be accessed. For
Hmm.
example, in if you visit some crowded place and you try to connect your earbuds, then that earbud gets connected with some other person also,
Hmm.
because your advertising name displayed there, and if they connect it before you, then that get connected.
But how they know the UUID of our services and all?
Because mobile phones are already configured in such way that they don't need UUID. They auto connect with these things.
Yes, 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 yes. So how to secure that?
You cannot secure it if your application is in such way. For example, mobile operators have to make their application in such way that user don't get many problem, and they don't have to write UUID and everything every time. So they have programmed their software in such way.
Hmm. But but I
But
think they
if
can
you
connect
want to,
connect
but
with our chip, but they cannot able to send the data
yeah, they
without.
will not. Yeah, they will not be able to send the data, but they will be able to receive the data, because your
Okay.
device will be continuously transmitting the data.
Mm-hmm. Got it. Okay.
But if you want to secure it, for example, your application is such that it transmits your data to only one or two device, then you can secure it that if you will get the UUID of the other device and program in such way that my BLE will only transmit data to this particular to UUID.
Mm-hmm.
But you cannot program this in your mobile phone because Bluetooth earbuds can be many and mobile phones can also be many.
Okay.
Okay, so I think we should wind up this class today. Next class will be the last class in which I'll demonstrate BLE. Okay, Valmiki sir?
Yes, I think we can wind up to here only. If you guys have any point, any doubt, just let us know. If not, then we can wind up to here.